We're replacing a $10 million quantum computer with a $10 piece of hardware.
You repeat that one for our audience just so it sets in for them.
In terms of quantum level internet security, we're replacing a $10 million quantum computer with a $10 piece of hardware.
If the weakest links are people, then that's what the hackers do. They go after people. If the weakest link is the backend, for example, the database, well, what it really means is that you're always one step, before you can get hacked. It's just one step, one person. I think the fundamental problem is that you're relying on people to do the job right, and they don't always do it right.
When it comes to logistics and supply chain and automotive manufacturing, the more data you can collect, in a secure and inexpensive manner, the better decisions you can make. You can make these informed decisions.
For example, people think of security as being basically that somebody's, hacking into your system. In reality, there are three problems that you have to always think of, which is data generation, data communication, and data storage. And these are three different problems, and they require three different solutions.
I'll just kind of keep that high level there. But yeah, we want everyone to be able to do business freely for a lot cheaper and not ever worry about getting hacked. And that's our primary goal at the end of the day, which sounds crazy again, but the goal is to create unhackable internet security. And we want that to be seamless to the user.
Welcome to the Secure CyberConnect podcast with Jay Adamson and Warren Atkinson, where we're joined by information cybersecurity, technology, and talent acquisition professionals who share their journeys, unique perspectives, and offer advice and guidance.
Our topics on this episode will be quantum level internet security using blockchain and cellular automata. Today, we're thrilled to be joined by Hamid and Mike. Hamid is CEO, founder, and chief architect of SQE, an award-winning design, engineer, inventor, and technology executive with over 30 years of experience and more than 20 US and international patents across computer science, electrical engineering, robotics, AI, and advanced algorithm design. His career includes developing the genetic algorithm behind the industry-leading TACO 0013 circulator, inventing a breakthrough 3D camera system referenced by Fortune 100 companies, and serving as CTO for multiple technology firms, whilst earning additional patents for high energy power switching and energy reduction systems. He's a longtime president of General Sensors, CTO of Growgenics, and mechanical engineering graduate of the University of Rhode Island. Mike is CEO and CFO of SQE, an accomplished finance and operations professional with experience in emerging technologies at EMC and within global financial analysis at Boston Consulting Group, specializing in financial planning, detailed analysis, and competitor intelligence. Most recently, as general manager of cultivation and processing at Sanctuary Medicinals, he's led a team of 100 plus developing effective structures, standard operating procedures, and streamlined production strategies. He holds a Bachelor of Business Administration in Finance with a minor in Information Technology from the Eisenberg School of Management at the University of Massachusetts campus. Hamid, Mike, welcome to the Secure CyberConnect podcast, and thank you for joining us today.
Thank you.
Thank you for having us.
Jay and myself, I'm really looking forward to the discussion. It's not very often that we bring together CFOs and technology leaders, and I feel that today's session is going to bring great perspective to our audience. And as we get into things, Mike, could you give us a high-level review of what we're looking at discussing today?
Yeah, absolutely. Thank you, guys. So first, we're going to be looking at quantum level internet security using classical hardware, which is hard to believe, but we actually just got our patent approved on this. We found out yesterday after 3+ years in the making. So extremely excited about that. So this isn't kind of another PQC algorithm. It's not QKD. It's not another QRNG. This is something very different and outside the box to solve this problem that people have seen. So we're going to talk about how Hamid and the SQE team pretty much took a stab at rebuilding the internet security model from the ground up, from hardware to encryption to identity verification to build the most secure internet platform to ever exist. And then secondary is blockchain. One thing we don't talk about enough probably from our team is that SQE's quantum secure encryption is built in and around the foundation of our layer 1 blockchain. And the kicker is it's as scalable and as low cost as you can get.
That's really fascinating stuff. Can't wait to unpack all of that. And Hamid, do you mind sharing with the audience perhaps a challenge that you faced in your career and how that shaped your views and perspective on cybersecurity?
Absolutely. So as you indicated, I'm an engineer. I've been an engineer all my life, and I have developed many products for many companies. And some years ago, I was working on a project in agriculture, and I realized that I needed to add security. Now, I can tell you, I'm not an encryption person by schooling. I had to learn by my own way of different technologies. And when I finally said, okay, I have to add security to the system, I realized that the cost of security was higher than the cost of the product I was designing. It was kind of like I just spent years developing this extremely low-cost sensory system for agriculture, except that is useless. I can't use it. So being basically a hobbyist in quantum physics and being a mathematician ever since I remember, and being an engineer, it just hit me that I can actually simulate quantum entanglement using Wolfram's model of physics using cellular automata. So I literally implemented his technology, and I have actually mentioned that to him, and he was very interested that to hear that you can actually use his theoretical physics to do real physical things using this methodology. So yeah, by doing so, I basically was able to a little bit like cheat in terms of entanglement, but really achieve the same results. But it's really more about superposition, how you can actually simulate superposition in a way that no one has ever done this before. And the government granting us the patent is just an indication that this is quite a novel technology, and it just changes the game for everyone. Yeah.
No, certainly does. It's an horizon challenge. We know a lot of technology and security leaders are afraid to look at. So we do commend you and congratulations to you and the team.
Thank you.
So guys, let's get into a little bit more on what is clearly a security crisis out there at the moment. And Hamid, I'll go with you first on this one. Yeah, when breaches are still costing around 4.5 million, despite huge security spending, and where do you think that the fundamental structural weaknesses across the entire system that keeps letting these apparently simple mistakes cause such massive failures? Where do you see that?
Well, I mean, at the end of the day, I think we are relying on people, regular people, average people, to do a job that should have never been given to them. You expect somebody to remember a large password, right? People can't even remember what they had for breakfast, and you expect them to remember this. So what it means is that they're going to write it down. So passwords are a fundamental problem. But that is one part of it. So getting rid of the password is a step number one. But there's also a bigger problem that fundamentally, if you have to have a key to do the communication, well, you have to share the key, which means you have to manage the key, and which means you need to have super users. You're opening the gate for people to be able to essentially hack the system. Because it doesn't matter if you have the best system of communication, if somebody gets their hands on the key, or mathematically they can discover it, then it's the same difference. What's the difference, right? It's always the weakest link. If the weakest links are people, then that's what the hackers do. They go after people. If the weakest link is the backend, for example, the database. If you have to have a database that essentially holds the information, but you also want to make the database searchable. What it really means is that the database cannot be encrypted, right? Because you want to search it. Well, what it really means is that you're always one step, before you can get hacked. It's just one step, one person, one misusage of the password, or doing something that you shouldn't be doing. So I think the fundamental problem is that you're relying on people to do the job right, and they don't always do it right.
Absolutely. And Mike, SQE talks about resilience by design. For those of our audience that are maybe not aware of the term, what does that actually mean in simple terms? Yeah. And how does it fundamentally change a CISO's job from essentially just defending systems to actually designing uncompromisable ones?
Absolutely. So yeah, my mind immediately goes to decentralization, right? No single point of failure. And in my simple mind, I like to think of blockchain as, you have multiple copies of a database, and ideally it's geographically distributed as possible. But it won't scale unless you have the security, and that's what SQE brings, right? We have a hardware and a virtual blockchain that is so decentralized and scalable, it renders any type of physical attack impossible. And nobody's going to crack the encryption. There's not enough computational energy on Earth to do so. But additionally, decentralizing cloud providers, as we've seen, is recently, more important than ever. And we have built those capabilities into our system. So yeah, pretty resilient there. And in terms of the CISO challenge, SQE is really a proactive solution versus a reactive solution. I'll admit I'm very new to the cybersecurity world, but I'm learning more every day. But one thing that I noticed during my learning curve is how everything was really kind of reactive and kind of built on top of each other and kind of a lot of fragmented solutions. And obviously, it's getting worse with AI. And I like to think of SQE as kind of a fresh start for the internet in the most secure way possible. But to Hamid's point, a CISO might say, hey, you have unhackable encryption, that's great, but how do I make sure, the correct user is logging in, who I think it is? And that's another story. But
No, appreciate you sharing. Thank you.
And look, myself and Jay, we've been to many roundtables, board meetings, and there are whispers amongst security leaders that PKI is dead. So Hamid, I'm curious, if the core flaw in cybersecurity is using keys and passwords, why is the industry wasting billions on solutions like post-quantum cryptography, for instance, to optimize broken systems? And why, breaking it down for audience, why is key-based systems fundamentally wrong?
Well, the fundamental reason why key-based systems are wrong is mainly because there's a key. That means somebody has to manage it. But I think I want to answer your main question. Why are they spending all this money? Mainly because there just isn't another solution up until now. At the end of the day, there is a problem. You have to show that you're doing something to solve the problem. You may not be able to solve the problem entirely, but you do want to make attempts. For example, people think of security as being basically that somebody is, hacking into your system. In reality, there are three problems that you have to always think of, which is data generation, data communication, and data storage. And these are three different problems, and they require three different solutions. And we actually have three different solutions. But people don't think of it that way. They just say, I just got hacked. It's like as if there's just only one way to get hacked. We have identified 37 different ways that people can get hacked and answered every one of them individually. But I think the main reason is because people spend the money, because if they don't, then what? There was no other solution up until now. And regardless of how expensive a solution is, they're still going to try it. So like quantum computers are fantastic for computation. But when it comes to security, you don't need to have a quantum computer because it only solves one problem out of the three, only for communication. You still, unless you happen to have a quantum computer on everybody's lab desktop, well, you still need to connect to the quantum computer, which means you still have to verify people. These are all classical problems. And it also means that when you want to store the information on your laptop, well, that's not quantum. That's basically classical. So quantum computers solve one problem. Quantum key distribution solves another problem, but it's not going to be here for another 10 years. And then storage, the quantum computers just don't answer that anyway. But our solution applies to all three aspects of security.
No, that's interesting. And you've mentioned it in previous conversations, but how does the keyless digital particle architecture actually work? In simple terms, and how does that change the way that data is secured? from the moment it actually leaves devices?
Okay, so I'm just going to spend a bit more time on this because I know it's a question that everybody has. It is a fundamental question. So there are three aspects to quantum particles. Aspect number one is that when you create a particle, which we do based on an actual quantum processes, we digitize them. So we digitize real quantum particles, and once we digitize them, then we can copy them. That copying is essentially our answer of entanglement. When two parameters are the same, they're essentially the same. It doesn't matter if they run on one machine or on another machine. So the second problem that arises is, okay, well, imagine they just got copied, therefore they're entangled, but let's say we send one of them to London and the other one is in New York. How is it that they're synchronized? Well, that's a different process. That's our synchronization process. So we have a process that we basically have a single global time base where every one of the devices, whether it's your phone or your mobile phone or our hardware or our mining devices or anything, our servers, the backend, they all adhere to the same exact time base, regardless of whether you're in actual communication. If I could just make a simple example, imagine that you're in London and you're looking at the London Tower. Everybody looks at the same time. I don't need to talk to you in order to have the same time as you. I synchronize mine with the global time. You synchronize it with the global time. The only difference is that the global time in this case happened to be a particle. It's a 1,000-digit number that I have no idea how to interpret it. You don't know how to interpret it. All we know is that if I make my time a bit faster or a bit slower so that my time particle becomes the same as yours, and how do you know that? Is because when I send a message to you, you can decrypt it. If you didn't have the right time, you wouldn't be able to decrypt it. So that's how essentially how we do our entanglement. The superposition just means that these are large numbers and are being modified based on another technology that we want to still patent. And essentially what it means is that it doesn't matter where they are. If you look at them at any given time, they just look like noise. So it comes down to what we call time observation. It is my belief, I'm not a quantum physicist, it is my belief that with the subspace is where things happen in the real world. It is the subspace that materializes particle in the real world. So we simulated the subspace, and when information gets transferred, and by information I mean particles, digitized version of particles, when they materialize, it's because time gets observed. So by simulating that, we're achieving the same thing as a real time particle. So I truly believe that time is a particle. I actually have talked to 2 quantum physicists so far who agreed with me that time is a particle. Most physicists don't agree with that. Again, I'm not a quantum physicist. I'm just trying to get a job done. So, yeah.
In and around that, are there any additional challenges to the norm that you wanted to highlight?
Sure. Yeah. I mean, this is, I really open just a a can of worms. It really gets deep into it because when you treat particles as numbers, right? Then essentially what happens to that number when it's a random number? How do you achieve that? Well, if I basically followed the footsteps of Stephen Wolfram, he actually has a methodology that describes quantum particles, which he calls basically a branchial space and multivary in the branchial space. Multivary means that essentially you can start from one state and get to the next state, but you don't have to follow the same path. It's like 2 people leave New York and they get to Boston using 2 different paths, right? Well, if you looked at them while they're traveling, you might ask, how is it that this guy is going in this route and this guy is going this way? But it doesn't matter. That's before they're in our universe. This is in the subspace. When they get to Boston is when they enter our universe. This is the same exact methodology that I'm using, so that essentially, even though they're essentially in a random state or a superposition of the random states, when they finally get observed, they both happen to be the exact same value, which is the key that is shared between them. And I'd like to keep it at that level, not go any deeper at this point.
No, that's fascinating. Thank you for sharing.
Yeah, nicely broken down. And talking a bit more about identity systems, in some of our more recent roundtable discussions, we've certainly focused on topics such as how deepfakes are killing many organizations and in terms of their MFA systems and the assumptions that go along with them. In terms of MFA and identity systems, Mike, and how they're clearly becoming highly vulnerable to issues such as deepfakes, internal lateral movement. How does your single unforgeable identity, your secure quantum identification platform, or SQUID, as it's known, permanently stop these sophisticated threats and prevent them from happening?
So it's not about securing authentication of an identity in one way. It's about doing it in multiple ways. As Hamid spoke about earlier, passwords are one example of that, but unfortunately everyone's password is stolen now. And then also the latest news with Google Nano Pro, I think it's Google Nano Banana Pro. That news about the hyper-realistic photos being generated in seconds. It's biometrics are even more vulnerable than ever. But I want to highlight one kind of passwordless technology that is an example of something new that we're bringing to the table. It's what we call SQE's zero knowledge keypad. So pretty much it's part of any login process, and anyone could go on our sandbox and use it today. But it's pretty much a page that pops up during your login process. It's a funky looking, digital keypad that changes every couple seconds. And a user simply clicks in a 4-digit code. It could be a 2-factor code. It could be their PIN. But eventually, neither of those will be needed because it's not about a PIN or 2-factor. It's about mouse movement, click rhythm, timing, micro interactions to create a profile that is very important part that is never stored or transmitted, right? So this is zero knowledge proof at its finest. And in terms of lateral movement, someone definitely needs to fix the problem of a worker, if they have a bad day, having the ability to shut down a whole operation if they get upset just because they have access. And I'll just say this, that there should never be a super user, as Hamid talked about before. And SQE will make sure of that with our blockchain and smart contract capabilities.
Yeah, interesting. And Hamid, in terms of migrating identity, it's clearly a pretty imposing and terrifying prospect for any CISO. What's the least disruptive, fastest path for an enterprise-led business to transition all its users and devices onto a more universal and forgeable identity system, such as the SQUID?
I think it has to be done gradually. You cannot shock the system. You have to do this in steps. And I believe using our zero knowledge for identity is the first step. But the idea is this. The idea is that you start from something that is very, very familiar to the way people use the system. Maybe just make a slight changes. And over time, what we are doing is, at least based on our system, over time, we are learning about the user in ways that, frankly, I'm not able to share more details about it right now. We are learning more and more, and as we are learning more and more, we are asking less and less from the user. And gradually over time, people realize that they're no longer being asked for the password, or they're no longer even have to put in their username. Frankly, the system, not personally, I just want to add one thing. I cannot even hack my own information in our own system. Okay, everything in SQE is secure by design. Everything is encrypted using very large encryption keys. I just wanted to add that as a side note. But frankly, the system knows about you better than you know about yourself. But none of the information that the system knows are things that can actually be recorded. So we are not recording any information about your location, your behavior, or nothing. This is essentially, imagine if I would describe it this way. Imagine if I have a copy of you, except that the copy just has 2 legs and 2 arms and a head. Little by little, I'm adding eyes, nose, fingerprint. Little by little, there is a copy of you in the backend in a form of a neural network. Okay, it's an AI that replicates you, but very little at a time. And eventually, it knows all your behaviors, it knows everything about you, but it learned it in a way that you learned yourself when you were a baby. Okay, when you do that a little bit at a time, it's not going to shock the system. So people will eventually realize that, you know what, I'm not getting hacked anymore. I'm not getting nonsense emails anymore. I'm not, you know what I'm saying? So you have to do it gradually because you have to follow the pace of people, not AI. AI can go really, really fast and destroy things. But I do want to add one more note about, basically deepfake mitigation. It's important to realize that at the end of the day, if you don't rely on facial information or voice or fingerprint, well, then if you don't rely, it doesn't matter if people copy it, right? But more importantly, deepfake does a much bigger damage, right? The bigger damage is that if somebody basically makes a copy of me and puts something out there. So there's only one solution to that as far as I can think of. And the solution is that you have to assume everything is fake, 100% until proven otherwise. And that's how we want to mitigate this. We want to say that if there is a video out there of me, if I say that it's not fake, if I say that it's not real, then it's not real. You just solve the biggest problem. So if you truly want something to be real, make sure that when you generate it, you follow the proper steps. And if the proper steps are not followed, then it's automatically fake. It doesn't matter if it's even me. This way, you kind of like solve the problem in reverse, and essentially the deepfake becomes a thing of the past. People have to learn over time. This is not something that you can gain in 10 minutes. It's something that you have to realize that, oh, this does not have the signature. It doesn't matter if I generated myself or some deep fake. That there's nothing we can do about. AI is way more advanced than we can imagine, right? And quantum AI has not even entered yet. And when that happens, that's even worse. So the assumption is that everything is fake unless otherwise guaranteed, verified.
Fair enough. Appreciate you sharing.
Yeah, I think from those that I engage with at grassroots level, I think they're becoming more conscious. A lot of individuals, of course, are conscious of false information, misinformation, and I think deepfakes is the next wave of that as such. And I hope that society are prepared. And like I said, there are some telltale signs that we are moving in the right direction, and there is a resilience there. Now, Jay and myself have worked on and with teams across the globe, and one thing's certainly true, and there's one thing that we hear quite a lot now, is that zero trust is slow and it doesn't scale well. So, Hamid, could you tell us a little bit more about building continuous identity verification right into layer 1 of blockchain, and how that helps organizations, for instance, achieve millions of transactions per second without sacrificing security?
I need to mention something. I think there's a misconception. Zero trust, if it's going to be used for every transaction, it's slow. But if I'm only using it during the login process, well, then it's only used once. How could it be slow? The problem that we have is that people, because of lack of other solutions up until now, they had no choice than to use zero trust in that fashion. Simulated quantum entanglement is as fast as it can possibly get. In fact, if you look at the energy cost for our per transaction on our platform, it's actually lower than even centralized systems. Okay, the cost of the energy of a centralized system, we can calculate that, and we have, and you will find that actually the methodology we are using is even lower cost. But I think a better question is, why do people think that the only way to create security is to have, for example, proof of work or proof of a stake in terms of blockchain? Well, the only reason why they're doing it is because of two reasons. Number one, Bitcoin was the first. Therefore, it has a special place. It's also digital gold. It has that, for whether it's true or not, that's what people think of it, right? But the most important reason why things like Bitcoin and Ethereum are popular is because of their security. There is no other reason other than that. I mean, otherwise, a centralized network works much faster, much cheaper, much better, but it doesn't have the security. So if you remove the security issues, which is the number one reason, in other words, any given transaction on a Bitcoin requires about 10 million computers and several hundred trillion operations. Okay? Well, if a single operation can achieve the same thing, but also do it even more secure, then why would you need to do it that way? So the answer is no, it is not going to be more expensive. In fact, it's just, it's just lower cost and more secure. That's my answer. I mean, honestly, I was asked in 2015 if I could design a system to increase the speed of Bitcoin generation and mining. And I thought about it. And because I've been a consultant for such a long time, my conclusion was, okay, let's say I just did that. What about the next guy? He's just got to come and make my device obsolete. And that's what we've seen in Bitcoin mining. Like the people who really make the money are the people that are making Bitcoin mining devices. Those are the guys who are making all the money, because as soon as you make one system to do it faster, the problem gets bigger, and now you need a newer system to do it. So it's just the wrong direction. That's why I decided not to take that project back in 2015. In hindsight, maybe I should have done that and made myself some low-cost Bitcoins, but that was my decision at that time. So yeah, when I was designing our mining system, that cost and energy consumption was number one. How can you achieve both? How can you achieve the lowest cost, but also the lowest energy? Because we should not be wasting energy, in my opinion, for security. This solution works great. And yeah, that's my comment.
I appreciate you sharing. And, hypothetically speaking, if the worst happens, what's the single most practical advantage of these immutable, real-time audit logs and systems? And what are the advantages that they give security operations teams during fast-moving and high-stakes incidents?
If I were to just pinpoint one thing, it would have to be traceability. The fact of the matter is that from the moment that a transaction is initiated, which means before you even start the transaction, you have to verify the user, right? Which means essentially it is almost impossible to actually have the failure happen. But if it does happen, again, it's one of those situations where it's hypothetical, right? But if it does happen, well, then you can follow it completely and you can reverse the process. You cannot reverse the blockchain. That is impossible by design. However, you can take the effect of it, which is a smart contract. There's a smart contract that essentially does the job, whatever the job happened to be, whether it's to turn the light on and off or whether it's to transfer money from one account to another account. In our realm, everything is reversible, but only with the proper permission. In other words, it is a smart contract that does the job. It is another smart contract that reverses the effect, not the steps. You can't remove the steps. Once the information enters the blockchain, it's immutable. You can't do anything about it. However, you can easily detect it, and you can relatively easily reverse it. Okay, that's the reason. But it is traceability. That's number one reason why we can handle these things. Yeah.
No, that's brilliant. And Mike, great to hear your perspective from a CFO standpoint. How does that translate into both business benefit and value?
Yeah, for sure. I would just keep this one simple and say that, the right smart contract system with the right blockchain, you can automate a lot of things. You can automate a lot of paperwork, less manual hours. And of course, that results in higher margins and lower costs for a CFO.
So let's talk a little bit about the sustainability topic, really. We know it's big on everybody's list at the moment: ethics, sustainability, return on investment, green security, if you will. Hamid, your platform, it's apparently up to 16,000 times more energy efficient than any of your competitors. What's the core architectural secret, as opposed to the consensus model, that delivers this seemingly massive sustainability advantage?
If I were to just give you one answer, it would be SQE, simulated quantum entanglement. The fact that we do not need to have 10 million or 100 million copies of the same transaction in order to secure it. If I can do it with a single transaction and get the same security, obviously that is one of the reasons. But I think at the end of the day, we're not making a simple statement. We are not saying that, oh, we have a distributed system, but there's only one transaction, right? What we are saying is that there are multifaceted issues here. For example, you could just lose the transaction because of a slow internet. You could lose the transaction because halfway through the transaction, a computer shut down. So the purpose of the blockchain and this communication scheme is not to create a better security. It just means that creating resiliency and robustness in the system. So theoretically, we don't need a blockchain. Well, we need the blockchain for user verification, but in terms of transaction, we would not need it. However, since I cannot go ahead and solve everybody's problem, what I like to do is I like to basically create 50 transactions, each one of them just as secure as any other one. However, if I lose some of them because of other reasons that are not under my control, it's very, very hard to lose. If given at any moment a system that was fully operational a second ago, most likely will still be operational. But if I'm going to lose something, I may lose 5% of it, or 10%, or 20%. But the chance that 50 specific systems that happen to be involved in a single transaction, all 50 of them fail exactly at the same time, even though none of them are next to each other, that's pretty slim. If you calculate the number, you'll find that this might happen maybe 1 billion years from now. But the probability of 50 systems that without designing them to be next to each other, in other words, they just happen to be random, failing the same time, same way, it's so small that is the reason why we actually use a blockchain for our transaction for unseen things that are not under our control. Otherwise, every single transaction by itself is good enough.
Yeah, makes sense. Makes sense. And Mike, with these transactions costing as low as $200 to the $1,000, what previously impossible sort of security applications, such as logging every single tiny event across things such as sort of maybe a massive IoT fleet or edge device. How is this now economically viable?
Yeah, absolutely. So it pretty much means now that, anything is possible in terms of tokenization and smart contracts. As Hamid said, the whole problem he was trying to solve is building this agricultural sensor, and he realized the security was more expensive than the actual product. And, he started that mission years ago, before I even knew Hamid, and he started with building a new blockchain to accomplish that. And over the years, it's come full circle now. And he uses that same security that he created from the blockchain now for some of our hardware products that, for example, Q chip. It's a chip that can pretty much be integrated into any type of IoT device, right? So, yeah, just so many more possibilities in that regard.
Why is it so important?
So when it comes to data matters, right? That's really a lot of my background is data analytics, and when it comes to logistics and supply chain and automotive manufacturing, the more data you can collect, in a secure and inexpensive manner, the better decisions you can make. You can make these informed decisions. So I'll just kind of give two kind of examples of some of our proof of concepts. When it comes to dental chairs, right? You can put one of these Q chips in a dental chair and have it securely communicate to the internet, right? Now you can automate that process. If there's ever an issue with the chair, the manufacturer can get an automatic notification. And you could save so much money there just from taking out that kind of middleman in terms of figuring out the problem, right? And you also don't need to worry about getting hacked through your dental chair for something like ransomware to shut down a dental office. But now just take that example and apply it to pretty much any medical device. That's this low cost advantage we have with our hardware products. It could be pretty much applied to anything. Another great example is the agricultural world, right? When I was in indoor cannabis, again, every piece of data mattered to me, but it just got very expensive if you wanted to monitor 20,000 plants all at the same time. Hamid and the team have created a system where that's doable now, right? And you can measure moisture levels in the root zone, and just being able to do that, every minute or so is so valuable and equates to so much money saved and gained. And again, expand that to food, ag tech, so on and so forth.
Absolutely. Makes sense.
And Hamid, you obviously come from an advanced engineering and AI background. What's the biggest limiting assumption in classical cybersecurity that you immediately recognize as fundamentally broken?
I think it's identity verification. It's really the biggest challenge. If you are not sure who the user is, there is only one solution, and the solution is don't let them do whatever they want to do. But that also stops doing business. I think that's what I have to suggest. It's basically user verification. It is actually, yes, it is definitely user verification, but I also want to expand it to something else. AI is advancing at enormous rate. And frankly, for the last 10, 15 years, I have a statement that I make, and that is that questions are the answers. If you ask the right question, you always find the answers. We have never been this close that if you ask the right question from AI system, pretty much you get any answer. So securing your questions is the actual problem. Because if I can ask the same question than you can, then we both can get the same answer, right? So, however, instead of looking for hiding your solutions, you should hide your questions. And so questions are generated on your machine, which means the security of the machine becomes more important than AI. Okay, and frankly, I've asked that question from many AI researchers, and every single time, without security, AI is almost obsolete. Yeah, I mean, it's not obsolete in the sense that it solves a lot of problems, but it's obsolete in the sense that why should I try to ask the question? I'll let somebody else ask it, then I just hack them and get the same answer, right? So it is important to realize that security is even more important than AI. And so, yeah, it's user verification. You have to make sure that the right person is the one who's asking the right question.
And so would you say identity is now the new perimeter?
Absolutely. And I think it's always been like that. We just didn't really pay attention to it. Identity has always been the number one reason that people, throughout the history, if you thought you were talking to the wrong person, or if you thought you were talking to the right person and you gave them false information, it could, backstab you. It can work against you. I mean, look at all the wars. It's like, it's all about the same thing, is identity. If you pretend to be somebody else, you can do a lot of damage. In the age of computers and internet, that's 10 times worse. But it has always been the case. It's not a new problem.
I appreciate you sharing. And what critical lessons can traditional security architects learn from fields such as algorithmic design and robotic control systems to ensure that they're building infrastructures that are generally secure by design?
Well, I think when it comes to robotics specifically, I've studied robotics in schooling back in 1983. I was a student of robotics. It's really, when it comes to robots, you have two problems. It's not just identity of the user, but it's also identity of the system. Okay, because nobody really hacks a robot themselves, because robots are automated machinery. They require devices. So device security, the same thing that applies to people, now applies to devices. You have to make sure that when you have a request being made by an automated system, that automated system is the right system. And what we call that, instead of calling it KYC, we have a new name for it. We call it KYD. You have to know your data and devices. Okay, so we actually have a process for that, where we don't just verify a user, we also have a different process to verify devices. That's why it's, as Mike just mentioned, what we call the Q chip and a Q link. These are two products that we are introducing, and their job is exactly that. So that after you are verified as a user, now we have to make sure that the devices that you want to authorize are also the right devices, because the problem is exactly the same way. It's always the weakest link. If the weakest link happened to be the device, then why shouldn't the hackers hack the device instead of you? So unless you want to do the job yourself by hand, well, in case of robotics, you're not doing it. You're asking a robot to do something, right? Then we have to make sure that the requests that are generated by you are carried out by proper devices. So we propagate this identity throughout the entire system. Okay, so that's I guess that's what my answer is. Yeah.
Yeah, it sounds like it certainly would help with some of the challenges a lot of the security leaders in the European space are facing at the moment, especially with the Cyber Resilience Act, for instance. You need to be able to audit those systems within critical national infrastructure and OT and thus forth.
I agree.
So let's talk a little bit about the term you've used, the Qverse. And I think of all the questions I've asked on the pod, this definitely is one of the most technically complicated. But the Cubverse maps data into a quantum secure 3D coordinate system. So what's the real world performance benefit that this 3D mapping actually delivers for these complex context-aware search and data retrievals over, say, a more traditional database?
So actually, we started with a more traditional SQL database, but soon I realized that, without having a proper search, you really are only solving half the problem. So vector databases, and there are several versions of them out there. Vector databases have fundamental benefit that you can actually search based on characteristics as opposed to based on actual, pictures or whatever, right? If you want to look for a red car, you don't need actually have a red car picture of red car. You can describe it, and a vector database can do the search for you. So once I realized that in order to have the information encrypted, I really cannot have any kind of database. It has to be a special database where I can search the database and still not have access to the information. The Cubverse was the solution to that. But while I was doing that, I realized that, Metaverse is fantastic. It does a lot of things. It's great. It's the future. And I truly believe that. But Metaverse is really made for people, not for data. Cubverse is essentially the same as Metaverse, except that it's for data. My goal is not to store videos, TikTok, things like that. My goal is to store information related to people, and information in terms of, it might even be a video, but that's not really the purpose. It's not to go and, look at a video. And what it is that if there is information about the video, it will be extracted, and that extraction puts you in a place in Cubverse. So most of Cubverse are not places where you actually physically go because it's too large. We simulate 200 light years with a resolution of 1 micron. If you search a billion location, even given any second, you would not even be able to cover 0.1% of it in a lifetime. But what it is basically where the information is, tells you a lot about it. Now, one big issue over here is that when you do conversion from, for example, a search engine to a three-dimensional, well, the search criteria is a lot higher than three-dimension. So we've done two things in here. We have basically taken information. First, we break it down into its pieces in terms of its features. Then once we identify the features, which by the way, it could be like 1,000 features, it could be 500 different features that if I only had the information about the feature, I would be able to completely reproduce the same thing, right? This is like kind of like for people who are a bit technical, this would be going from like time domain to frequency domain uses an FFT. And then while you're in the FFT, fast Fourier transform, while you're in the frequency domain, you might decide that, okay, I don't really need all the frequencies. Maybe I'll just delete some of them. And when you convert them back into time domain, you have something that looks like the real thing, but it's not the real thing. But for all practical purposes, it has the same functionality. This is essentially what we do with information. When somebody submits a picture of a house to us, we break it down into 500 different dimensions. And then what we do is we take those 500 dimensions and find the best location in Cubverse that best represents things that have any given aspect of that specific house, for example. In other words, if it's a red house, then a portion of this house is next to other red things. If it's, so basically, instead of having a 500 dimension entity, we have 500 one dimension entity. But each one of those 500 is individually searchable. So I might be able to say, show me all the red houses. Well, it goes to all the red things are and all the house things are, and it combines them, says what is common between them, and it shows you that, which means now you can actually do a search for something that doesn't actually exist. I can tell you, nobody else can do that. Okay? So
appreciate you breaking it down. Thank you. And I'm sure the word Qverse will be as widely used as metaverse and multiverse in no time at all out there. Mike, you'll be pleased to know the next question is not quite as challenging for you, but in terms of sort of tying data access to the squared and at the file level, fundamentally making that regulatory compliance, such as sort of HIPAA and GDPR, automatic, sort of immutable and provable, instead of a manual, expensive audit process. How does that break down?
Our network it's as granular as you can get, as you heard Hamid talk about the Cubverse itself. And sometimes you guys will get caught saying the word encryption key just because that's a term that's easier to relate to traditional cybersecurity. But what is really going on is, every endpoint or device has this constantly flowing stream of random bits, right, that are being merged with data at one point and unmerged with data at another point. No key exchange. So every bit of data gets its own bit of encryption, right? Think about how powerful that is. And that's also kind of how I like to think of how our identity works, right? Every single entity on our platform gets this 1024-bit SQID, right? So every person, every mobile phone, every laptop, every dollar, picture every dollar you've ever owned, every dollar bill has your picture on the dollar bill. Even if somebody stole it, nobody could do anything with it. So every asset has the user's information encrypted into the asset, into that 1024-bit SQID. So kind of transparency through the roof, if you would. But rule number one, right, is you should only have access to the data that you should have access to, right? So principle of least privilege. And in terms of, the automation and immutability of it, the blockchain side is so important to that. And I'm actually surprised we haven't brought this up yet, but one extremely important feature of our blockchain, every single transaction or every block only has one transaction, right? So the audit trail for every step of a process has, it's as transparent as possible. Of course, as long as you have the proper access.
Yeah, well, I was going to ask you why that's so important for many CFOs, but I think you've kind of answered that already.
Fair. Yeah.
And Hamid, I know in other interviews, yourself and your colleagues, you spoke about reinventing DevSecOps, for instance, and you mentioned earlier in the interview your governance model and how you're mapping that, using that to map it and ensure that there's a level of resilience. Part of that, of course, we understand is multi-part contract approval and banning external libraries, for instance. So you're taking more of a secure by design approach. And we often meet with leaders that feel that secure by design, especially within the enterprise space, can be slow by design. What are your thoughts on that?
All I can tell you is that not only is not slow in our system, it is quite fast. But I think the main reason for being slow is because when you don't have a fundamental solution, you have to use a lot of other, non-fundamental solutions and pile them together to create somewhat of a good solution. That is the part that's slow. Deciding, for example, which algorithm should be used for this type of data. These are things that should be automated. This is not something that should be manual. The beauty of blockchain and the resiliency of blockchain is that, well, the data decides what methodology should be used, not the user. It's seamless from the user's point of view that I just want to store my information. But if it happened that the information happened to be stored on a server, then it should have a different characteristics because different people have access to it than if it's going to be stored on your own laptop. If it's going to be stored in your laptop, then you should have a system where essentially it should be isolated. And you should be the only person who can access it. But once you put it on a server, so the data decides to do it. Unfortunately, a lot of people who are professionals, they don't appreciate that. They like to break it down and essentially do this somewhat manual. And by manual, I mean like tools that exist, but they have to select the right tool. I think this is just by design. One of the things that I've learned over the years of being a product development engineer is that 70% of the cost of a product can be reduced during the design time. In other words, the material is only 30%. 70% is controlled by design. We just want to make sure that by design, we have the lowest cost system. So therefore, it's just low cost to begin with. And low cost means low time. And also it means that it's fully automated. If the data decides where to go, then you don't need to make the decision. It's as simple as that.
Yeah, and we hear a lot of concerns around development space, especially when it comes to code and software, for instance. We know that a lot of organizations are using vulnerable third-party code within their products. So, what tips or practical guidance would you give development teams to ensure that they can potentially move away from relying on vulnerable third-party code and start building out more immutable security code pipelines?
I discovered this, unfortunately, the hard way. Not being a back-end engineer myself, I was continuously faced by back-end engineers telling me, "Oh, we have to do this. We have to do this. Like, we have to use containers. We have, it's Docker container. It's like," I'm going like, "Wait a minute. This is way too complicated." And this complication means entry into problems. Let's simplify the problem. The problem is this. If you're a developer, you should only have access to the development data. If you're a tester, you should only have access to a tester data. And if you are an executive who decides when to release the data or when to update the server, then your job is to make a decision, is not to write the code. If you happen to be a single individual doing all of them, well, then you have to do all of them. That's a different story. But for organization, that's their problem. So what I did was I removed this functionality from individuals and put it into a smart contract. It is the smart contract that decides when the data should get transferred. And we apply that completely. What it really means is that you don't need to have 50 people to verify things. the verification should be done by the guy whose job is to verify. And the testing should be done by the guy whose job is testing. By automating this process, we decided that CI/CD, the way it is not good enough. And that's where the problem is. So we have created our own CI/CD process where there is no super user. Okay? And if as soon as you remove the need for a super user, you just reduce your headache by 70-80%, in my opinion. Because it is having a super user that creates the problem. If you don't have a password, then you don't need to reproduce it. Then, you don't need to hide it. You don't need to manage it. You can get rid of so much of it by just getting rid of the problem. Throughout my professional life, many times I have solved the problem by removing things as opposed to adding. You'll be amazed how often you can do that in a design. Identify what is absolutely needed and what is not needed. And a lot of times, the problem just disappears as soon as you remove things that are not needed. Identify them is the job of and the engineer. But that's how we've done it. We basically decided that the normal containers are not the good solution. So we created our own solution, and we've been testing that. And frankly, we're not 100% done with that yet. We're kind of like a mixture of CI/CD the way it was and the way we are trying to create it. But over time, in the next few months, I think we'll be able to completely finish that. And so that essentially the final decision is by the person who's responsible for the problem. It's not because one guy made a mistake, like last year, some guy at Microsoft screwed up at 2:00 in the morning or something. And next thing we know that they got hacked and millions of computers were unoperational. And yeah, that just should not be possible. You cannot rely on a person to never make a mistake. It's natural. We're all human and we may all make mistakes. But the fact that there was a possibility for a person to do that was the problem, not the person. So by removing that, you solve this problem.
Very briefly, could you give us a prediction on how you feel the DevSecOps space perhaps is going to evolve over the next 5 years? And do you think it's a viable career pathway for individuals that are looking to enter the cybersecurity remit, for instance?
Honestly, I haven't thought about this question, but I think we are at the infancy, even today. Honestly, I'm old enough to remember some of the original advertisements by IBM where Charlie Chaplin was adding all the books with all the applications. And I'm going like, oh, maybe pretty much everything that we ever want to do is pretty much done. You don't need to get into computer science. That was 35 years ago. I'm realizing that now that we have not even solved 1% of human problem. I think we have a long way to go before we can say, okay, should I get into this tech? Of course, yeah, absolutely. The real problem have not even been started. The AI is just a beginning, in my opinion. It opens up the door to solutions to better humanity in ways that we have not even conceived. I cannot even think, but I mean, some of the science fiction movies, show you some of the possibilities. And those are all still there. If you ask me, we have not even solved 1% of the problems yet. And I can assure you, if we had another hour, I could tell you 100 problems today that could be solved this way, but they require engineers. Unfortunately, engineers are not the highest paid people. Some of them are lately, but really, engineers are the people who actually solve all the problems. I wish people appreciated them a bit more, being an engineer myself. But I think there is a long way to go before people should worry about that.
We can discuss the other 99% of problems on the next episode, Hamid, for sure. So talking a bit more about the return on investment piece, it's been clear to anyone watching the episode about the benefits here that the SQE brings in terms of, the architectural flip of the CEO, the CFO's mindset, and really turning that sort of dreaded money pit mentality of security into much more of a competitive advantage that can actually drive revenue. Mike, in your own sort of opinion, what are the three most critical dollar value metrics, for a return on security investment or cost per incident that every security leader should be looking at to communicate the value of keyless architecture to a CFO or the board?
Definitely. So, when you're looking at cost per incident, right, it's obviously growing by the year, seemingly regardless of what industry you're looking at, right? So you're looking at 5 to 10 million per incident on average, which is pretty wild. And obviously, I think that gives a great benchmark of kind of how big the problem is. And eliminating the attack surface is our goal, right? And it starts with that keyless approach. We eliminate the attack vector altogether for a quantum computer, but it shouldn't stop there. And that's not the end all be all solution. Everyone knows you got to get rid of passwords. We talked about getting rid of super users. So it's you really got to get rid of the attack surface, and that's our goal at the end of the day. And just almost by coincidence, well, not by coincidence, by Hamid's brain, it'll happen to be probably 90% less cost of traditional solutions today to do that with SQE. And of course, we're happy when customers gain margin. And I know these are crazy things to say, but this is kind of really a different world of technology disruption. In terms of kind of return on investment, I'll steal Hamid's quote here, especially since our patent was just approved. In terms of quantum level internet security, we're replacing a $10 million quantum computer with a $10 piece of hardware. So I'll just leave that one there.
You repeat that one for our audience just so it sets in for them.
In terms of quantum level internet security, we're replacing a $10 million quantum computer with a $10 piece of hardware.
Perfect.
Brilliant. And look, for our audience, we're certainly going to be putting some links in this episode. So keep an eye out for that.
and Mike, if or should I say when SQE continues its success, what is the biggest, most positive change that the average person, the consumer or the employee or the patient in healthcare would notice about their own digital life?
Yeah, I'll try to summarize kind of what Hamid was talking about earlier. But the goal at the end of the day is they shouldn't need to worry about a thing, right, when they're operating in the digital landscape. And on the kind of other side of the coin, if you will, once the blockchain, the SQE blockchain ecosystem takes off, there's going to be so many opportunities, so many money-making opportunities for enterprise and consumers. I'll just kind of keep that high level there. But yeah, we want everyone to be able to do business freely for a lot cheaper and not ever worry about getting hacked. And that's our primary goal at the end of the day, which sounds crazy again. But the goal is to create unhackable internet security, and we want that to be seamless to the user.
Damn, you've got me excited, guys, for sure. Absolutely. And Hamid, for any entrepreneurs or scale-up founders, watching this, how does adopting this architecture give them an unfair, defensible advantage in the market against slower legacy competitors? Just to finish off on this.
I think, at the end of the day, I have been an independent consultant all my life. And, for the last few years, I've been acting like a CEO. But really, I'm just leveling the area of the arena for everybody so that essentially the same thing that the internet did for people and the same thing that like 3D printers did for manufacturing. You don't need to have a huge investment upfront to enter markets that you really should be in those markets because of your talent, but you couldn't have done it before because of the initial investment requirement. I think SQE opens the door so that if you just have a little idea and you think you have a better idea at somebody else, I don't want the initial investment of having your own network, having your own security. Even when it comes to maybe even bigger businesses, like a small bank, obviously not everybody is Bank of America where they can spend billions of dollars in security, but smaller banks, they cannot afford. So what it means is that the small banks may have to go out of business because the cost of security is, this actually is a statement that I was told by a bank manager, that the cost of security is higher than the insurance of all of their employees. Well, if that goes even higher, and I think it has a 40% growth, the cost of security, pretty soon none of the small banks can survive. Just reflect that to individuals. If it takes such a huge investment to create a new product and not be absolutely sure that your information is secure, then you would not be able to enter that market. But now we can secure you. At least when it comes to security, you don't have to worry about that. You can focus on your development of your what it is that you're trying to do, and I think that just levels the arena for everybody. I think that's the main reason. That's what we can do for people.
Yeah, love stuff.
So, Mike, could you tell us a little bit more about the types of organisation that you're working with at the moment, and who should be reaching out to for support?
Yeah, for sure. So you can kind of look at this a little bit on the software and the hardware side. So if I kind of split it up there, we have our sandbox up on our website. This allows anybody to just log into our sandbox from the browser, and they can see that zero knowledge keypad in action. They can see simulated messages and simulated payments in action with this keyless architecture. So our first initiative there is to really support platforms that are building and they want that added security and that cost effectiveness. So just seamlessly, anyone who has a website or an app, we just want them to see how easy it is and seamless it is to integrate our security bit by bit into their existing processes already. Right? There's no rip and replace. You don't need hardware on the software side. On the hardware side, like I was saying before, it's come from full circle from beginning the building the network to now having a plethora of IoT devices which all are integrated with our Q chip. So we're working with manufacturers and medical devices and in agriculture to bring that Q chip security and all the benefits that come with it to IoT devices. We think that's going to be where our first real killer use case is bringing this to Industry 4.0.
No, I appreciate you sharing it. And Hamid, any predictions for the future? Any final thoughts? And if our audience want to stay in contact, we're certainly going to put some links in the show notes. But what's the best way for people to reach out to you also?
Well, you can always go to our website, which is SQE.io. But just a simple search for SQE.io and you get all of our information. That's the easiest way to get in touch with us. We have a few people who are working with us in Europe. We have a few people in North America, in Canada, Mexico. These are people who joined our cause, and frankly, they've been working extremely hard. You can reach any of them, and you can get all the information about how to work with us, how to join us. Frankly, we are a startup at the end of the day. That means that we have to prioritize what we do. Our goal is to attract as many people as we can, and then identify what holes to plug. What is it that still we have missing that we have to cover so that we can have a complete A to Z solution. And solution means hardware, software, identification, application, implementation, and go on and on. But at the end of the day, they all have to do with security. The blockchain, our token, which, by the way, I should add, is going to be called Tachyon, which is Tachyon with a Q, TAQEIN. So a TAQ would be our token, TAQ. So let's call it TAC. And it's a special token. It's a utility token only. And essentially, people would be mining it themselves, and they can spend it on our platform. We will take it as a method of payment. And so basically they can just partner with us in just doing mining. They can partner with us to be a piece of Cubverse, because Cubverse is a distributed universe. In other words, it's not one database. It's a collection of individual machines, wherever they happen to be. They basically participate. There may be 10, 20, 50, 100 copies of the same information. We have no idea what information is where. All we know is that we have several backup copies of the entire system for ourselves, just to be safe. But then essentially when your laptop, for example, gets used, you make a little bit of money. Okay, so it's like, it's not just like mining. You share a corner of your computer to be a part of our Cubverse. And Cubverse says, okay, here's an empty space. Why don't I allocate it to this region? So little by little, you get a distributed information platform, but 100% encrypted, and only the right people have access to it. On SQE, we do not hold on to anybody's information other than your basic information, your name, the basic information that we need to work with banks, for example. But in terms of where you happen to be, what do you do, what do you drink, what do you eat, where do you work, none of that information is ever stored anywhere. We learn from the information and basically vectorize it and give you access to it. For example, if you have medical data, you can sell your own information. Why should companies sell your information? It's your information. You should decide. You can go ahead and market your information on our platform, and many, many, many other features like that. And honestly, like I said, we can talk about it for the next 100 hours. It's an unlimited possibilities when you look at information in this fashion, right? But 100% secure. I promise you, I will not have access to even my own information. And that is something that we are going to actually present in a public arena, show people how is it that I can basically be the head developer for this and not have access to my own information. But before I do that, I'd like to apply for a patent at the technology, which we are in the process of doing, so that it is a revolution. It is absolutely a revolution. We can talk about it in the future videos.
No, that's really fascinating. Jim, myself really enjoyed today, and really looking forward to perhaps having you and the team back on in the future, walk for a demo, live Q&A with some of our audience. So audience, if you are tuning in, watching, listening, make sure you hit that like button.
And I think revolution is definitely the word that probably springs to mind. Guys, we speak to a lot of startups, and we spoke to a few guests. When I first reached out to Mike some months ago, you definitely made it worth the wait, Mike. I think introducing today with yourself and Hamid, and it's been an absolutely cracking episode. I think you've both been wonderful, broke it down brilliantly, and game changing stuff. We wish you the very, very best, and I'm certain that SQE is going to be a transformative and game changing business going forward. So huge thank you to you both, guys. It's been wonderful to listen to your journey and your insights. Thank you.
Thank you, Jay. Thank you, Warren. Really appreciate the opportunity to showcase our technology.
So, guys, thanks for your time. I'm sure the community, all our listeners, will have found a huge amount of value in today's session. For people who want to continue the discussion and for more sustained engagement, as always, we invite you to join the Secure CyberConnect community on our channel, where we offer a range of collaborative solutions to both tech and security professionals at no cost. Expansive community access, mutual mentoring, online networking, and amazing and exclusive interviews such as this, with panel discussions and masterclasses thereafter. So thanks, guys.